Okay, turning to the next problem, it looks real similar to the last one. So we have to determine the head at point A and compare it to the water table. The gauge pressure now is negative 4950 pascals, and we are to use the red line as the datum. So first, let's write down the equations we'll need. We'll need H equals, well, that was weird, Z plus psi. And we know that psi is always equal to P over rho G. And we also know the constants that we need in this equation. We know the density of the water is 1,000 kilograms per meter cubed, and G is 9.81 seconds per meter squared. Both of those are MKS units. So first thing we're going to do is take this pressure and calculate the metric potential psi. So we're going to say psi for this point is equal to negative 4950 pascals, all in the MKS units, divided by the 1,000 kilograms per cubic meters, that's the density, times 9.81 meters per second squared, that's G, and we plug that in to our calculator. Let me go check and see what I get here for this problem. We get that it is negative 0.50, negative 0.50. Can you see that? Meters. Okay, there is psi. So as all these problems do, it comes down to determining Z. So once again, head is equal to Z plus psi. We've got psi. What is Z? So now we are to use the red line as our datum. And once again, we know that each step here is 10 centimeters. So let's do this. Actually, let's do this in centimeters. So negative 0.5 meters is equal to negative 50 centimeters. Why not? We can use centimeters. As long as both Z and psi are in the same unit, we can add or subtract them, right? So we're going to use centimeters for this problem. So psi is negative 50 centimeters, and so we need to measure Z in centimeters. So let's see. So point A is above the red line, so the elevation relative to that datum should be positive, and we'll just count it out. So that's 10, 20, 30, 40, 50, 60, 70. So this distance here is 70 centimeters, and that is therefore Z here, Z for A equals 70 positive 70 centimeters. So we can therefore write for A, this is for A, oops, wrong thing, the head at A equals Z at A, or 70 centimeters, plus psi, which is minus 50 centimeters, so it's just minus 50 centimeters, and that is equal to 20 centimeters. So the head at A is 20 centimeters. I'll just write that down. H equals 20 centimeters. All right, so now, as always, we're going to do the same thing because we are actually asked to determine whether water is flowing between the water table and A, or A, which way is it moving between A and the water table. So once again, we're going to pick a point right beneath it on the water table. We'll call that point B, and we're going to determine the head at point B. So at point B on the water table, we, as always, have Z, the elevation of point B, plus psi at point B. First part super easy, since psi is always equal to P over rho G. And at the water table, the pressure is equal to 0. The gauge pressure is equal to 0. Psi at the water table, at point B here, will equal 0. Psi is always 0 at the water table. The metric potential on the water table is always 0. So this thing here is 0. But the head is not. I'm sorry, the elevation head is not 0. We have to figure that out. In this case, it's really pretty easy because the water table is above the datum, and we can just count it out. So it's 1, 2, 3. So this is 30 centimeters. The water table is 30 centimeters above the datum. So Z for the water table, point B, is equal to plus 30 centimeters. And since H is equal to Z plus 0, then the head at the water table at point B has to also equal 30 centimeters. So these are my two values. Head here in green is equal to 30 centimeters. The head at point A, right up here, was 20 centimeters, and so the head is going, water is going to flow from high head to low head, from 30 to 20. It's going to flow up like that. There's my solution.